Hi all, today we'll be talking about a Leetcode problem, House Robber 3. Let us go through the problem statement first. The thief has found himself a new place for his thievery again. There is only one entrance to this area called root. Besides the root, each house has one and only one parent house. After a tour, the smart thief realized that all houses in this place form a binary tree. It will automatically contact the police if two directly linked houses are broken into onto the same night. Given the root of the binary tree, return the maximum amount of money the thief can rob without alerting the police. So basically, this question is a continuation of the house robber problem, where in the previous problems the houses were arranged linearly or in a circular fashion. However, here the houses are arranged in a binary tree. The constraint remains the same, that the robber cannot rob two houses which are directly connected. Let us go through the first example. Here the thief has two options. It can rob the root, and then since the root is robbed, it definitely cannot rob its children, so we'll skip the nodes 2 and 3 and then go to its children, go down one level. So the total profit the thief can make in this case is 3 plus 3 plus 1, which is 7. And the other possibility is that the thief did not rob the root node. It robbed its children. Then in that case, it would make a profit of 2 plus 3. However, it cannot rob the nodes at level 3 again because its parent is robbed. So the total profit in that case would be 5. However, the profit of 7 was greater, so it will rob the root node and these two other nodes. In the second example, if it drops the root node, it will have a total profit of 3 plus 1 plus 3 plus 1, which is 8. And if it doesn't drop the root node and goes for its children, it will have a total profit of 9. So the answer is 9. We might think of robbing on alternate levels, starting once we rob the root node and once without robbing the root node, but that wouldn't give us the correct answer. Suppose if we had a node, the root node had a value of 100 here, and there was another level, fourth level, with one node with value 100. The maximum profit in that case would be this 100 plus that 100, which is 200, rather than going on alternate levels. So we make two observations here, that if the parent node, if at the node we are currently at, if its parent is already robbed, if its parent is robbed, then the thief has no option, that then he has to skip the node. He cannot rob two consecutive houses. So if the parent is robbed, there's no choice rather than not robbing the current node. And if the parent is not robbed, the thief has two choices now. He could either rob this house or not rob this house. We will explore both the options and see which gives us more profit, and we'll take the maximum from both the possibilities of robbing and not robbing when the parent is also not robbed. So let us get into code. We'll do the basic check here. That is, if root is null, we'll simply return 0. Otherwise, we'll do recursion. I'll write a function recur here, which will pass in the root, and it will take a boolean variable which will tell us whether the parent is robbed or not robbed, because that is the only information we need to make decision for the children nodes. So for the root node, since there is no parent, we'll pass it as false, that its parent was not robbed, because to explore both the possibilities of robbing and not robbing the root node. Then we'll write this function recur tree node star root and boolean f. F denotes whether the parent is robbed or not robbed. We'll do the basic check. Root is equal to null. We'll return 0. Otherwise, we'll keep two variables, one for robbing case and one for not robbing case. So if our parent is robbed, if the parent is robbed, the thief has no option but to skip this node. That is, it will go into the not robbing case and it will simply recur for its children, that is root.left. And what information will be passed to the children of this node? The children of this node will get the information that the parent was not robbed because its grandparent was robbed, so the parent was not robbed. So we will pass the information of false here, and then we'll recur again for the right child and we'll pass the information that we were not robbed. The current node that we are at is not robbed because its parent was robbed. Else we get into the case where the thief has two choices, either to rob the node or to not rob the node because its parent was also not robbed. So if we go to the not robbed case, it will again be the exactly same condition that we wrote here, that we'll pass to our children that we were not robbed, and we'll recur for the children of the node. However, if we rob ourselves, like if the thief robs this node, the value of this node will get added to the overall maximum profit that we are attaining, and then we'll go into recursion for the root dot left, and we'll go into recursion for root dot right. And in this case, since the thief has robbed the current node, its children should know that the current node was robbed, so the children node should not be robbed. So we'll pass the information of true here to signify that that the current node is robbed, which will become the parent in the next recursion. Finally, we want to return the max of robbed and not robbed case. Let us try to compile this result. And we'll try to submit this. So this will give us time limit exceeded because we have written a recursive solution and the number of possibilities to explore are a lot since the number of nodes could be 10 to the power 4. We need some kind of memoization here to make it a bit faster. So we'll keep a map to memoize a result. Suppose we reach a node and if we have already reached this node previously, we don't want to compute for it again. We'll simply return the answer that we have memoized in our map. So we'll memoize the answer for it in our map. We'll keep a pair of Boolean and tree node and an int. The pair of Boolean and tree node signifies that the tree node is the current node we are at, and the bool signifies that whether it is the robbing case by which we have reached the current node, or the not robbing case by which we have reached the current node. And the value for this map will be an int, which will be the answer, the maximum value that we obtained at this particular node. It will store the answer at this node. So if here we'll check if our map.find make pair of f and root equals to sorry, not equals to mp.end, that means that this node was visited previously, so we will return mp make pair of f and root. And here we need to put the value that we have got in our map, so we'll put the value of map make pair f and root as not rob. Similarly, here we'll put in the map of make pair f and root as max of rob and not rob. Looks good. We've memoized our result. Let's try to compile this. Tree node. Okay, then should be capital. Looks good. Let us try to submit this. It is successful. So we saw that recursion with basic memoization gave us an accepted answer. Thank you so much for watching.